السلايد باينه كده، برزنتيشن باينه.
واضحه يا دكتور، واضحه.
تمام باين.
تمام. Okay, I will start the presentation titled Fourth Industrial Revolution in Wastewater Treatment Technologies. This will be illustration for the application of Fourth Industrial Revolution or Industry 4 in the wastewater treatment technologies. I will make it. I'm Mahmoud Nasr from Egypt. I'm the co-PI of the project titled Agriculture Sustainability and Water Use in Egypt, Innovative Wastewater Treatment and Soil Health. First, I would like to give a brief description about the evolution of the fourth industry, starting with the first revolution to the second, to the third, to the fourth. For the first industrial revolution started at 1700 by using steam for production of elements and for making products. And this steam was supported by human power, and it suffered after that from great pollution to the atmosphere due to using of the steam. Then after that, it becomes second revolution at the era of 1800 using electricity to support the industry. After that, it became the computation technique using computer and softwares for the third industrial revolution, starting from 1900, and the transformation to all the equipment to using computation and mobiles. All of these techniques reduces the human power and reduces the pollution to the atmosphere, including the utilization of fossil fuels and all of these inputs of
excuse me, Dr. Mahmoud, excuse me. I think we couldn't see the slides clearly because part of the slide is not is hidden upward. So yes, just decrease it. So it this is very good. Thank you.
Then after that, today we are at the era of the fourth industrial revolution with the using of the connection between remote sensing and mobile application and computation. And here we can see that the human power is reduced totally, and we are depending mainly on the equipment, remote sensing and computation to solve all the problems around us. So here is the question: what is the contribution of the fourth industrial revolution in the field of wastewater treatment? Do we use remote sensing, and do we use computation techniques, and do we use online monitoring during our application in wastewater treatment technologies? Yes, the answer is yes. Currently, we are not making physical inspection to wastewater treatment and physical inspection using human manpower for water bodies in remote areas. We are now depending mainly on using of the sensors and sending the sensor are measuring the water quality and measuring the water parameters, then send it by the data by the cloud, and the cloud will be accessible to all of the users after that in other countries. This is the current revolution application of the fourth industrial revolution in the field of water and wastewater and environmental engineering as a general. Yes, you can see also the same slide, but we can make clearly that the first industrial revolution depends on the steam, water power and mechanization. Then after that, in second revolution, it was electricity and mass production. Then we use computation. After that, in the fourth industry, we use cyber physical system with a connection between all the elements of computation. You can here see some elements of the fourth industry that build the industrial revolution. You can see big data analysis, robots, the utilization of robots to collect data from remote areas or hazard areas. So we depend on robots. We are making simulation, Internet of Things, cybersecurity. All of these are the elements of the fourth industrial revolution. And there is a broad application of these elements in the field of wastewater treatment and water treatment. And here in this presentation, we can give highlight of some of these applications. You can see here smart sensors used in the wastewater treatment system. You can see that this treatment plant is very huge, and to collect the data and to monitor or detect any problem in any tank, it may be some time consuming and effort consuming. So we are putting sensor at every tank. Sensor, for example, we can monitor dissolved oxygen in an aeration tank using sensors without physical inspection. And also we can monitor the sludge bulking or sludge accumulation in settling tanks to avoid sludge bulking or sludge foaming without physical inspection. All of these data are collected using sensors that are fixed in the lines and fixed in the tanks, and send the data to the SCADA system or computation system where there is a human. Only one man can monitor all this equipment, and he can detect if there is any error or if there is any drop in the treatment system to solve this quickly. So smart sensors are used in treatment plants. It's fixed in the lines, it's fixed in the tanks. It can monitor pH, it can monitor dissolved oxygen, it can monitor flow rates, any leakage in the pipes. All of these are, we depend on smart sensors. As you can see here, there is a fixation of some sensors in the waste influent, and in the treatment tank, you can see several sensors. We can have, for example, one sensor for monitoring of dissolved oxygen, and one sensor monitoring pH, and one sensor monitoring temperature. Then by using the data collected by these sensors, it is sent by the cloud server. Then there is access by the user to all of this data. So we can notice online what is occurring in the system. Another application of the fourth industrial revolution is the Internet of Things. Internet of Things has found several applications in environmental monitoring, in waste management, in air and water pollution, and extreme weather. Internet of Things is the same of remote sensing, use of the sensors, but it is integrated in a framework using computation and using the cloud and using the data analysis. All of this included in the Internet of Things. And you can see here that we are putting sensors in the water pipe between a leakage point in a pipeline. So to avoid that we are detecting leakage previously by making a hole in the streets and make an inspection, then this will too much wasting time and wasting effort. So by putting sensors before and after the line, we can detect the leakage and we can monitor, and we can notice that if there is leakage in this pipe or it's already fixed. Then we are using in Internet of Things, as I mentioned before, that all elements of fourth industrial revolution, including sensor, water meter, communication, then sending the data to the cloud. Then we can analyze data also using mobile or using softwares. All of these are applications that we found in the water and wastewater treatment. As you can see here, we are putting in situ water level sensor. This one application of Internet of Things. We are monitoring the water level in a river, for example, or any water body, then sending the data level sensor and collect it to the computation. Then we have real-time altering, and we can make hydrological modeling. So Internet of Things, we can summarize some elements like digitalization, big data, real-time monitoring, optimization, artificial intelligence, robotics. All of these are applications of Internet of Things that we can use during our to solve any problem in wastewater treatment system or any leakage in pipes or having a smart water system. Also, the fourth industrial revolution includes the application of mobile application. We can monitor or control any equipment in the treatment system using mobile, and we can notice, as you can see here, they are controlling or they are monitoring the pump or the air diffuser in one of the tanks, and it shows some information about operation time and temperature. Then we can notice by using mobile the data collected and the current condition of this aeration tank, including temperature and operation time. So noted that this operator can be at remote area or can be in another place, not measuring physical parameters or not measuring physically, by taking samples and grab samples and collecting samples. So now it's totally different. We are now in the fourth industrial revolution. Collecting samples become very low. We are not going now to the river or to the drainage system and collecting samples, grab samples, and all of this. The fourth industrial revolution is alternative to all of this. And you can see also here mobile application. It's very advanced, and we can monitor more than parameter. We can measure pressure of the pipe. We can measure some water quality parameters like pH, like temperature, all of this, and we can notice what is occurring in the system by online. And you can see here remote metering, like flow meter. It sends the data. You can see in the screen of the flow meter, you can see that it's monitoring the flow meter online, and we can send noted the data by sending it to the cloud. Then we can have access to all of this. Also, one of the applications of the fourth industrial revolution is the computation and artificial intelligence techniques. In this method, we are not using the traditional way of notice the equation of ordinary differential equation for the biomass growth rate and the biomass decay rate and substrate utilization rate. All of these are differential equations, and we have some models like activated sludge model 1, activated sludge model 2, and it contains about, I remember that activated sludge model 1 has about 13 differential equations. And each differential equations contains some parameters like stoichiometric parameters and kinetic parameters. And to solve all of this equation, it needs too much experimentation to determine each parameter. We have decay rate, we have growth rate, we have consumption rate for all bacteria like autotrophic. So you can imagine that we have several parameters. Using traditional way of solving this equation is very time consuming and too much effort to solve these equations simultaneously, especially that if we have several tanks in series. Currently we are using artificial intelligence technique, which is called the black box model. So we don't need to be expert, notice every parameter or notice every equation. Just we have some knowledge about neural network, for example, or fuzzy logic, for example. Then we have some input data, and we can predict the output data without introducing too much information about the system or about what is occurring in the bacteria or in the biological reactor system. I can show you one of several examples of application of computation. For example, for prediction of BOD in adsorption process, and I give you a link of the paper that I have recently published, that you can notice the application of computation for the prediction of some wastewater treatment problems. We have also artificial neural network has been applied in algae-based system to predict the biomass growth rate and to predict the removal efficiency of nutrients and pollution using algae. We predicted this using a neural network, which is one of the elements of the fourth industrial revolution. Several applications of neural networks can be found to predict algae or to predict pollution removal, like heavy metal removal, chromium removal, and all of this. I put some links that can be reference for the application of this modeling, how we can generate the model, how we determine the input parameters, how we determine the output parameters. All this needs some experience, because if you select input parameters that has no effect on the system, then the model is not valid. So before starting the model, artificial intelligence model, some experience should be available, so you can select the input and output parameters with the range, valid range of each parameter. Also, I introduced for you some of my special issues. It's called fourth industrial revolution of wastewater treatment with adsorption, and this I also the link that you can find, and you can find some publications that used fourth industrial revolution, including modeling, including remote sensing, including cloud and Internet of Things. Several papers are in this issue that you can find for solving some problems in the adsorption system of wastewater treatment. Also, fourth industrial revolution, I put also one of the links. Also, this is one of my issues for collecting some issue about fourth industrial revolution. Thank you for your attendance and participation, and I will be pleased if you have any question.
شكرا دكتور محمود. لو في اي حد عنده اسئله، حد من الحاضرين اسئله؟ محمد اشرف، ها؟
And ask any question that we can open.
Do you have any questions?
For example, if you are working in one of the point of your research and you want to discuss how we can apply modeling or how we can apply Internet of Things in your research, because it will be a very attractive point if you are including in your paper or your research one of the modeling. It will attract the editors and reviewers.
Thank you, Dr. Mahmoud, for your presentation. I was just wondering, could you give us some examples of the software that we can use to perform this modeling?
There is difference between technique and software. The technique that we are using, artificial intelligence, neural network, fuzzy logic, response surface methodology, all of these are techniques. To determine the best technique that fits your problem is need experience. You can apply neural network in some cases, and you can apply fuzzy logic in other cases, and you can apply statistical analysis in other cases. It depends on the distribution of the data and the amount of the number of the data that you have. This is a technique. Then we have to solve the technique. Then we have several softwares. For me, I use MATLAB. I use MATLAB to solve all the problem that I face. I use MATLAB to solve neural network. I use MATLAB for fuzzy logic. I use MATLAB for methodology, principal component analysis, character analysis. For me, MATLAB is best tool to solve all these problems. But as I told you, there is a difference between the software and the technique you are selecting from the beginning.
Okay, thank you, Doctor.
Thank you.
Usually I when I perform response methodology in my work for optimization of any condition, I use Statistica, and sometimes I use Microsoft Excel. But yeah, maybe I will start using MATLAB if it is better to use it for modeling and optimization. Thank you.
Okay, thank you. I think that Excel can solve some statistical analysis, but not all of them. For example, you cannot make clustering or principal component analysis by Excel. But if you are talented enough in MATLAB, I promise that you can solve any problem, including statistics, including artificial intelligence, and MATLAB is very helpful user interface, and you can find on the YouTube several tutorials, and you can find also several examples, solved examples in the library of the MATLAB itself. So I recommend that you can start using MATLAB for your future during all your research in the future.
Thank you, Dr. Mahmoud.
Thank you.
I have more questions regarding the using sensors to detect the factors in, or let me say, in the sustainable agriculture. They usually use sensors, different sensors, even for water quality assessment or for meteorological data or for soil quality assessment. Nowadays, there is wireless networks, sensors, but I'm wondering if these sensors are playing according to sensing or satellite images, whatever. I don't know the mechanism of using wireless networks for sensors. Can you have any explanation for using the wireless network sensors? They are working using the satellites or
Yes, as you have mentioned, yes, we have several sensors in the water quality parameters, pH, temperature, DO, and organic matter, all this. And we have some sensor for the physical parameters of the water, like the pressure in pipelines or the temperature, leakage, flow rate, all of this. And this depends on the voltage and amperes of the sensors. They are transforming signals using a code, computation code, receiving some signals from the sensor, then transform these signals into readings. And this reading will be saved in a library in the cloud, which will be accessed by the user after that.
Hopefully, I think we are beginning to use these networks and sensors in the new reclaimed areas beside the Mohammed Habib station. Many of green, and they are all controlled by sensors. And this is actually the kind of this is very.
Yes, this is very important, and it needs some integration between electrical engineering and computer science. And you see that environmental engineering now is a wide umbrella that several expertise can work. We can work civil engineering for the design of the reactors. We can have mechanical engineering for the defining the pumps. used in the reactors. We can have electrical engineering to design the software and to make automatic control in a system. And we have computer science engineering also to make the computation system. All of this environmental engineering is a very wide umbrella that cover all of this. So in the past, there was a sanitary engineer who solved all these problems, but due to too much pollution and due to the water system now received several pollution and several chemicals, so the background of sanitary engineer is not enough to solve the problem. Then we need some chemical engineer to solve with him the problem. We need to civil engineer, we need mechanical engineer. We also need some of the financial background to determine if this system will be feasible or not feasible, economically feasible. So to solve one problem using environmental aspect, we should have integration between several background experiences.
Okay. If we don't have any extra questions, can we return back to the first slide? So I want to have a photo for your first slide when you are talking about the title of your presentation, please.
Okay, yes. I think it's fine because it will shut
yes,
down.
This is very nice.
Yes, okay.
And afterward, I think we can open our cameras to document this lecture and have photos for all participants. Please open your camera. Stop sharing the slides, please, Mahmoud. Yes, thank you. All participants, please open your cameras. I need to have a photo for your participation, to document your participation. I didn't see any participant to open their camera. Can you hear me?
We are all open our camera. I guess there's
hi, Mohammed.
connection.
Okay, we need to have a photo, group photo, please. علاء, are you here? دكتور علاء.
ايوه يا دكتور مع حضرتك. ثواني بس الكاميرا مش شغاله. ثواني.
تمام اوكي عشان
صورة وهعمل حاجة.
اوكي شكرا يا بابا.
هو دكتور علاء حاطط صورته باين يعني معروف في الصورة هتبان هتعدي محدش هيشوف إنها الصورة.
Okay, thank you, and I will send you the link of the presentation from the YouTube.
Thank you, Dr. Mahmoud. Thank you very much.
Thank you. Thank you.
And I have one request, please. Can you share with us your recent paper regarding the fourth revolution? I have heard from you that you have already published a nice review article about the fourth revolution. Can you share it with us in the group?
It's called the computation-based approach for predicting BOD.
Yes.
For, sustainable management of wastewater plants using artificial intelligence techniques.
Yes.
In soft computing techniques in solid waste and waste water.
Can you share it with us in the group? Okay.
Yes, it includes some information about.
So you can share it with us in the group.